Hi, Professor Ramesh. Very nice to talk to you today.
Same here.
Now, Professor Ramesh happens to be the youngest professor in University Malaya. That's a little bit interesting. He's also created this object called the TZP ceramic, which has got mechanical strength and apparently has the ability to conduct electricity. You're going to tell us a little bit about it now?
Yeah, okay. TZP is, the full name is tetragonal zirconia polycrystal. Basically, this ceramic exhibit, if you look at the face, it is tetragonal face. In this invention, it is not common for TZP, especially in the tetragonal phase, to conduct electricity at room temperature.
Okay.
So in this research, what we have done is we actually played around with the composition and the processing in order to create a ceramic through microstructural engineering. We actually created a ceramic which can conduct electricity at room temperature and also maintain the mechanical strength. Most of the time in this sort of development work, if we improve one property, we normally lose the other. And that is the difficult part in the biggest challenge in trying to balance the mechanical and the electrical as well.
But in your TZP ceramic, you have managed to balance both mechanical and conductivity.
Yes, we managed to preserve the mechanical strength, so we don't sacrifice the mechanical properties, but at the same time we managed to make the ceramic to conduct electricity. The conductivity, the way how the metal, the ceramic behave, it's like a metal. It has very low resistivity and high conductivity. So immediately when it is exposed to electricity, it conducts, exactly like a metal conductor.
That's why you decide to go for the ceramic, because
right.
It behaves similarly to the steel.
That's true. The other reason why we decided for ceramic is there's a lot of requests from the industry. Metallic conductors are normally exposed to harsh environment, a steam environment, acidic environment, and so on. Now, as a result, over time, they corrode. And therefore, you need replacement of the conductors and so on.
Right.
Now, ceramic, it is corrosion resistance. It has mechanical strength. TZP has the elasticity of TZP is the same as metal, and sometimes this material is also called ceramic steel. So what we have decided to do is to choose ceramic because it has the mechanical properties that normally a conductor would require. Plus, we just engineer the ceramic so that it conducts electricity. And basically, that's what we did.
So now, what are the applications which we can use the TZP ceramic for?
Okay, of course, for this invention, it's a conductive ceramic. So we are looking at any application that requires a material that does not corrode, but at the same time to conduct electricity.
Okay.
The invention, of course, I could also engineer the material not to conduct electricity, and it can be used for other applications, mechanical applications such as cutting tool, biomedical applications such as implant and so on, because this material is bio-inert. So one part of my research also look at the development of prosthetic implants, and basically we use ceramic, TZP, and also hydroxyapatite.
Now, is the cost for TZP ceramic expensive?
This is fine ceramic. It is not like the clay-based product that we are all familiar with, and therefore it has to be processed in order to be in a nanometer scale or micron scale, depending on the application. On a small quantity, it can be expensive, but of course, if we are doing mass production, so the cost will be offset. Another thing is that with such a small quantity of this material, because of long lifespan, so you don't have to replace components so often.
It becomes cost effective.
So it becomes cost effective at the end of the day.
Okay, I think you must have a good product because I hear that a UK company has shown an interest in commercializing your product. In fact, they've already commissioned you guys to do something.
That's right. There's a UK company called Spyrex Sarco. They are an international boiler manufacturer. They have showed great interest in this work because they have experimented with a lot of ceramics, and most of the time they said that the ceramic would fail when they exposed to steam environment after a certain period of time. So in this case, we managed to develop this material to be corrosion resistant, And we have sent them samples and they have tested in their actual boiler setting, not in a lab setting, in an actual boiler setting, and they were impressed with the outcome of the material. The material did not degrade or break into pieces. And now they have given me specific dimensions of the type of conductors that they want me to actually manufacture. And I think they don't want to buy the IP because they don't have the expertise in ceramics. So we are looking at probably contract manufacturing. So we would manufacture the component and we will sell it to them.
Very good. Congratulations. I think you got a great product there. I also hear that you're a grade B professor now. You got one step away before you become grade C, right?
Grade A.
Grade A. I'm so sorry. Okay, it was very nice talking to you, Professor.
Sure. Okay. Thank you.
All right, thank you.